We're going to move on next to Jason Johnston. He's from Verizon. He's going to talk to us about performance and optimization, which seems like a natural sort of follow-on to your work, Oleg. So, Jason, I'll leave it to you, and thank you, Oleg.
Awesome, great. Thank you, Oleg. If you can still hear this, I'm a big fan of your work and the R3F community in general. So, thank you. It's great. All right, let me share my slides. I think maybe this is coming up. There we go. All right, hey everybody. My name is Jason Johnston. I work at Verizon. I work specifically in the network security group there. I build UIs and data visualizations for network security, and I utilize a lot of 3D and XR. I also build tools to drive a lot of those experiences, and a lot of those that I've managed to open source under the Troika project, which it includes a sort of React-inspired scene management framework oriented around performance. But probably the most popular part of it is its text rendering library for very high-quality text. But I'm not talking about that today. Today I was thrilled to be invited to talk to the community about performance and optimization. It's a huge subject. And then I realized I only had about 10 minutes to talk. And so this was an exercise in optimization itself. I really had to focus and say, okay, what am I going to focus on in this talk? I decided that what I should do is really focus on a very high level, define what our performance constraints are in a WebXR environment, give a little bit of an overview of the general approach that I like to take when I start thinking about performance, and finally talk a little bit about some things on the future horizon that can help us out. To narrow the scope even further, this talk is going to be totally based from my personal experience. And I came into this space as a traditional web developer, trying to get into 3D and XR. And a lot of my work is mostly in UI and data visualization. And I think those things tend to be more like diagrammatic in nature. So I don't typically deal with very complex geometries or large textures, but I can have a lot of very simple objects that are very dynamic. And that definitely affects where my bottlenecks tend to occur. Also, my experience is also almost entirely in the 3JS community. So some of these things might not directly apply to other rendering libraries. Finally, I want to mention that most of what I'm going to talk about isn't necessarily specific to WebXR. It really applies to any WebGL work that you might do. But many of these problems tend to compound themselves once you step into WebXR. So let's get started. When we talk about performance in WebXR, what we really mean is frame rate. That's what's crucial. That's what's hard to maintain. So what kind of frame rate are we talking about? Let's take the Oculus Quest 2, for example. It's perfectly capable of driving WebXR content at a full 90 frames a second. If you can do that, you're great. I find 60 frames per second is perfectly good, perfectly smooth. 45 frames a second, this is where you start feeling a little bit of jitter, a little bit choppy, but it's mostly acceptable in that range. Anything below that, however, you're getting into the danger zone for causing motion sickness. And I tend to be a little bit more sensitive than a lot of people to this. It definitely affects how much time I can spend in VR. Something else I want to mention is the frame rate's important, but also what's important is the steadiness of frame rate. If most of your frames are very, very fast, but you have some situations where maybe you're doing a big scene update and you drop several frames in a row, that can be super bad for the experience as well. So keep that in mind. So with our best case of 90 frames a second, that's about 11 milliseconds per frame in which all of your work has to occur. That's a very different sort of performance limitation than web developers like me might be used to. I think the rule of thumb used to be 100 milliseconds for visual feedback for users to feel instantaneous. Totally different than 11 milliseconds. And so let's try to break that down a little bit. Within that frame, you've got things that happen on the CPU and then on the GPU. On the CPU, a ton of things that can happen. Incomplete list here. Physics simulation, animations, updating poses. You're probably doing raycasting maybe twice if you're using both controllers. event handling, other game logic, etc., network requests, data processing. And then finally, you get to 3JS render process, which itself does a lot of things behind the scenes until it gets to issuing draw calls to the GPU. And you probably issue, if you're in VR, you're issuing those draw calls twice. And then on the GPU, stuff happens. I'm not going to go into detail here. I'm intentionally glossing over this for two reasons. First of all, it's way too deep a subject, and it's not really in my expertise. But maybe more importantly, I think, honestly, it's not that important in most use cases, at least in my experience. That's because once stuff is on the GPU, generally, that's going to run just as fast as it would be if you were driving it with a native framework. However, the stuff that happens on the CPU, this is where our web environment, our web execution environment comes into play. We're using JavaScript, which is a scripted language. We have garbage collection to deal with. It's largely single-threaded in nature. And so this is where we typically need to concentrate our efforts, I find. I'd love to dive into more detail here, but for time's sake, let me just kind of step through what goes through my head when I start thinking about optimizing an app. So this is the general process that goes through my mind. Number one, I've got to measure it. I've got to know what I'm dealing with. Number two, I start asking myself some questions. Can I do less? Can I do less each frame, more specifically? On the main, can I take stuff off the main thread, maybe put it on a web worker? Can I do less on the CPU? And finally, with what's left over, can I just do that more efficiently? Stepping in a little bit, how to measure. I like to have a frames per second meter in my VR scene that I can pull up at any time, gives me a nice overview. But anything more detailed than that, I need the browser dev tools, hook up the profiler. And from that, I should be able to get a nice flame chart of all my JavaScript calls, see what's taking a long time, and focus my optimization efforts there. From there, I want to start asking questions. Is there stuff that I can do less of? This might involve making some tough choices. Can you simplify? These are in no particular order, by the way, these questions to ask. But it's always something to keep in the back of your head. Can I do less? More specifically, are there things that are happening on every single frame that I can be smarter about and maybe do those only on certain frames, only when they're needed? Can I adopt a reactive model where I'm only updating things when they change? Can I do caching? Little sidebar here, I'd like to talk about 3JS. This is a 3JS specific problem. The matrix auto update flag. This is something that's true by default on every object. And what it means is that on every single frame, every single object is going to have its local and world matrices recalculated. And you can imagine that doing this on every frame can be pretty intensive. There is a way to turn it off and do it manually. However, that's kind of hard to do as an author. I think there's a huge opportunity here for framework authors, people writing frameworks that sit above 3JS to add some help here and manage this automatically. The Troika framework that I've created does this, for example. I think Mozilla Hubs has something similar. I don't believe that React 3 Fiber or A-Frame do something similar, and so this is an opportunity perhaps for those frameworks to look into. Not only does cutting out matrix recalculation save some time every frame, but it turns out that once you track and know when individual objects are changing, you can do other smart stuff. For example, in Troika, I use that information to maintain an octree for much faster raycasting, and also for automatic instancing. All right, so back to the questions. Is there stuff that I can parallelize into a web worker, take it off the main thread? Anything that's data intensive and can work asynchronously is a prime target here. Point you briefly to the Troika work utils package. Has a few utilities there for making that a little bit easier. Can I do less on the CPU? Put differently, can I take advantage of the power of the GPU to make things faster? The big thing here is, this kind of maybe doesn't fit exactly into this slide, but one of the biggest wins that you can have is minimizing your draw calls. Draw call is a command from the CPU to the GPU to render an object. And the fewer of those you have, there's a fixed cost per draw call, basically. General rule of thumb, in VR, you want to keep the count below 50, and that can be really hard to do. Some techniques you might use are merging geometries together and using GPU instancing. 3JS has a nice instance mesh abstraction for doing that, for example. Something I've started doing more recently is using custom vertex shaders for things where I have a geometry that needs to be morphed every frame. So a quick example of that here on the right. Each of these sort of candy ribbons on the timeline are is just an instanced set of box geometries that the vertex shader is bending into these nice paths. And that's super fast, super fluid. And the Troika 3 utils package allows you to, has some utilities for extending built-in 3JS materials to make that sort of stuff easier. As always, though, you need to measure the trade-offs. It's not always a win to move things that way. And then what's left? Can I do it more efficiently? This is your normal micro optimizations come into play here. Some opportunity for WebAssembly to be used if you have sort of data intensive processes that could be converted to WebAssembly, so potential there. Okay, so finally, I just want to touch on some things coming in the near future that can help us out. Multi-view extension. This actually used to exist in 3JS. It was removed for various issues, not least of which is the lack of anti-aliasing in the official version. The upside is it could potentially cut the draw calls in half in VR contexts, so a big win there. WebXR layers, lots of potential there for performance improvement. Better tools for using WebAssembly. I'm just starting to get into WebAssembly, and it can be tough coming from a JavaScript background. So better tools there would help. And then the big one, WebGPU. When this comes to us, I'm not sure when it'll happen. This is going to bring a lot of sort of automatic performance improvements. My understanding is that, for example, that fixed cost per draw call would pretty much go away. So that brings me to the end of my word salad here. Thanks for listening. Like I said, a lot that I couldn't cover. But if there are any questions, I would love to take them in the final minute here. I'm not sure if anybody is around to give me questions. Hey there, Trevor.
Hey, Jason. I think looking at the timing of it, I think we're actually going to have to skip questions today, but the Slido is up. So I think maybe one way to handle this is that, one, we have an after party, so people will be able to find you afterwards, hopefully, but then also, where can they find you on Twitter?
On Twitter, I'm Logic. That's Logic with 2 J's instead of a G.